So the question becomes, what the heck is dimensional analysis? Well, dimensional analysis is probably one of the more useful things you'll learn in chemistry. A lot of students come back to me after they've graduated and gone on to college and their careers, and they've said that this was probably the most useful thing that they learned in chemistry. So we have to ask the question, what is it? Well, dimensional analysis is a method for converting units. So in chemistry, we use several units, more than several. Examples of units, again, are things like the meter, which we use in M, centimeter, milliliter, liter, just various different units of measurement. We use the gram, milligram. And you've learned all of the units, hopefully, from previous lectures that we had in class. And you should have a grasp of those before getting into dimensional analysis. But the whole idea is, if I want to know how many kilometers exist when I have a certain amount of meters, I can use dimensional analysis for that. So it's just a way of getting from one to the other, and vice versa too. It works in reverse. So it's a great setup for that. So let's look at an example. I think it's best to look at examples first and then talk about how they're set up. So let's look at one example here to start off with. It's kind of on the easy side. So we have the question posed to us. It says, how many meters are in 5 kilometers? Now, this is a question that would, be applicable to track stars and athletes and cross-country runners. But also, just if you're driving in another country besides the United States that use the metric system, this might be something you'd want to convert at some point. Regardless, you'll have to do it in class, so it's good to know how to set this up. So I look at the question, and I see 5 kilometers, and that's the only thing I have to work with at this point. So in the setup, I start off with 5 kilometers. So let me write that at the top. And we'll put 5.00 km for kilometers. Now you notice that I've got this thing in what looks like a fraction, and it is, and there's actually a 1 there that we don't usually write. We don't usually need to write the 1, it's assumed. But you'll notice that I've got kilometers in the top, and what I'm going to do is put in a rate. So the left side is known as the given amount. Okay, the left side, the first fraction is known as the given amount, and that's what's given to me in the question. It's what I have, it's what I know. That's what I know. We have 5 kilometers. What we want to get it into is meters, and that comes in the form of something known as the rate or rate factor. And again, according to the notes in your textbook, the rate is just a fraction. Now, when you have this set up for this fraction, we put the kilometers down at the bottom, because anything divided by itself equals 1, which would eventually cancel these guys out. On the top, I'm going to put meters, which is what I desire to get, and that goes there. So the rate is always set up like this, but you want to have the rate set so that the units themselves will cancel out, meaning I've got kilometers up here and kilometers down there. There's a diagonal pattern there that has to occur. When that happens, this guy and this guy will cancel out, and you'll be left with this guy, which is what you want in the first place, because the question is how many meters. Okay, so we need to put some values in here, and if you remember back to our units notes, we have kilometers. It has a prefix, so whatever unit has the prefix, in this case kilo, we put a 1 there. You have to know the meaning of kilo to figure out what to put in the top part of the fraction. We need to know what goes there, and to do that you need to know your unit prefixes. Well, kilo means 1,000, and so you can either write 1,000 or 10 to the third, and so we have this setup. Now again, if you look at the kilometers, the kilometer units are going to cancel. You've got km's there, and m for meters there. When we do the math, we're going to see that all we have to do is take this number, multiply it times that number, and divide by 1. Now, we don't usually divide by 1 in a calculator, because whatever is divided by 1 is still that same number. So we'll just do 5 times 1,000, which you guys know is 5,000, for an answer. If you remember our discussion of significant figures or significant digits, This 5.00 kilometers has 3 sig figs in it. So we've got the 5. Any numbers after the decimal are considered significant. And so we have 3 sig figs there. This is considered an infinite value, meaning there are exactly 1,000 meters in 1 kilometer. So they get infinite sig figs. So I always go with a given amount to figure out how many sig figs the answer should be rounded to. And so when we look at the answer, we have 5,000. But if I just write it like that, that's only 1 sig according to the sig fig rules. And so in this case, I would just write it in scientific notation, which would be 5.00 times 10 to the third meters. And that would be my answer. It's a good habit to box the answers so that the teacher, and in your case me, knows what your correct answer is. Okay, for that. So that's one example. Let's look at another one. Okay, in this example it says convert 200 milliliters to liters. So let me go ahead and put up the setup for this one and you can take a look at it. Okay, so you can see in our setup that we have 200 milliliters up here. So the 200 milliliters is all that we have in the question so far. And so that's our given amount. And again, the given amount goes in the top left of this 4-quadrant setup. Okay, and since 200 milliliters is all we know, that's what goes in there. It's what we have. It's what's given. Okay, the other side will be the rate side. So I've pointed to the rate side with a red arrow there. The 10 to the negative 3 liters, the reason for that is, again, milli means 10 to the negative 3. So if I have 1 milliliter, that is 1 times 10 to the negative 3 liters. Okay, and so we put that there. Now again, the milliliters, the way that they are set up, will cancel each other out. Anything on top of itself in a fraction divided will equal 1, which is a cancellation. In the top right unit corner, we have liters, which is what we wanted in the first place. And so when we go to do the math on this, we have 200 times 10 to the negative 3, which gives us a value of 0.200 liters. Okay, boxing my answer to show the teacher, the instructor, what my answer is, and we're good to go. So it's a real simple way to get these things converted. It does require that you understand the metric system or the SI unit system and that you know your prefixes so that you can get the rate down correctly. If you don't have that down, you need to go back and study that and get those memorized. Okay, this next question is how many seconds are in 43 years? On October 23rd, 2015 at 11:59 a.m., I turned 43 years of age. And at that exact moment, I was a certain number of seconds old. And so in this question, we're converting from years, in my case 43, to seconds. Now, this involves several steps because I don't know how many seconds are in 1 year. So let me show you the setup for this one, the steps, and we'll go through and explain it. So we look at this setup, and it's, as you'll notice, it's several steps. So as far as how many steps it is, going from 43 years to 365 days is one step. Going from days to hours is another step, and then hours to minutes is another, minutes to second is another. So we have 1, 2, 3, 4 steps in this problem, and it seems like a lot to do, but when we look at the setup here, it should make some sense now. If you look at where everything is set up, we have years here and years here. Notice again that diagonal pattern. Here we have days, 365 days, and days here which cancel out. Okay. In 1 day there are 24 hours. Down here we have hours, and the hours cancel out. There's a repeating pattern of cancellations on the diagonal. 1 hour is 60 minutes. We have minutes up there, and 1 minute is 60 seconds. And so the minutes cancel out, and guess what we're left with? If I set this up correctly, what I want is in the top right, which is seconds in this case, because the question is simply asking for seconds. Okay. And so we do the math on this, and so in a calculator, I would put 43 times 365 times 24 times 60 times 60, and I would get my answer in that case. Now, it equals 1,356,048,000 seconds. Okay. Based on rounding in sig figs, which we've done in class, we could also write this in the correct sig figs, which should be 2 because 43 has 2 sig figs. The rest of these are considered infinite. And so in that case, I would write it as 1.4 times 10 to the, let's see, 369 seconds. So at that exact moment when I turned 43, I was 1.4 times 10 to the 9 seconds, approximately. Now you might be thinking, well, Markarian, that is a lot of work. And you're right, it is a lot of work, but consider the alternative. If I asked you a question like that and you didn't know how to set it up in this way, it could be a much more difficult problem to deal with. And so dimensional analysis, while it's work, is really a tool. And it's a tool meant to make things easier for you, not more difficult. So once you learn the tool, it really makes chemistry easy, a lot easier than it needs to be, or that it is. Okay, so let's do one last example here. And it says, how many hours is 340 seconds? So we're going to calculate the number of hours in that amount of seconds. So let me show you the setup. Okay, so in this example, we start off with 340 seconds. That is our given amount. That's what's given to us. So again, remember that goes in the top left. There is a 1 that would go there, but we don't usually write it. Okay. If you look at cancellation of units, if we start out with seconds, then you need to have seconds down there. I know there are 60 seconds in 1 minute, so minutes go on the top. Since I have minutes up there, I need to have minutes down there, which will cancel, and I know that 1 hour is 60 minutes. Now, in the calculator for this one, we don't have 1s on the bottom, we have 60s. So when we go to put this in the calculator, I type in 340. Now it's times 1 and then times 1 again. So it'd be 340 times that times that. I'm just going to show that here in case it's not 1. But if it's 1, obviously 340 times 1 times 1 is still 340. Okay. The next move I make, if I'm not using parentheses in the calculator, is to divide by 60. That is this one. Then I need to divide by the next 60. What you don't want to do is times 60 at this point. It is not 60 times 60. You're dividing the top by the bottom. Since there's two things and they're both 60, I have to divide by 60 and then divide by 60 again. Okay, so that's one way to do it in a calculator. Another is 340. Again, we'll put the times 1 and times 1. Then divide, then parentheses 60 times 60. If you parenthesize it, it keeps both of those things on the bottom where they remain. If you don't parenthesize, you have to do it this way. Okay. Either way, you're going to get the same answer, which is, let's see, let's calculate it. Let's see, it comes out to 0.0944 hours. So 340 seconds is considerably less than an hour, which makes sense. If you count to 340, you'll be well within an hour. It's a very small portion of an hour. Okay, box my answer, and that's the setup for that one. Okay, so we need to ask the question, what did we learn today in this video? One of the first things that we hopefully picked up from this is that dimensional analysis is a useful method for converting units in chemistry and in use in other sciences, not to mention just everyday things like converting units at the store when you're trying to get a deal on something. Dimensional analysis has a distinctive setup of the given amount times the rate, and we always use that when we're doing the conversions. Units should cancel, and what you want goes in the top right of the setup, thus really eliminating the need to do a lot of thinking when you're doing this. If you know the setup and you know how to use it, it really cuts down on the amount of thought that has to go into this stuff. It's useful beyond the class and probably one of the more important things that we'll learn this semester.